welcome. How is everyone this afternoon? Woo! Over your afternoon slump and ready for this exciting discussion on generative AI. If you are wondering how to productize generative AI, how to do it performantly and cost effectively, what are the different considerations when deploying generative AI at scale, then you've come to the right session. My name is Shruti Koparkar, and I am on the product marketing team here at AWS. And I will be your host and moderator for this session. And joining me is this panel of 4 very smart, very experienced people. We have Ron Diamond, who is a senior principal engineer at AWS. He is the chief architect of AWS Trainium and AWS Inferentia, our purpose-built machine learning accelerators. Next, we have Jon Stoica. Jon is a professor of electrical engineering and computer science at UC Berkeley. He is also the co-founder and executive chairman at Databricks and Anyscale. Then we have Naveen Rao. Naveen is the VP of Generative AI at Databricks. He came to Databricks as part of the Mosaic ML acquisition, who he was the CEO and co-founder for. And then finally, we have Pete Werner. Pete is the head of AI at Leonardo.ai, an exciting startup out of Sydney that is building a generative AI-powered content generation platform for creators. A very warm welcome to all of you, and a very warm welcome to our audience as well. Now, before we get started with this discussion, we wanted to get a sense of who is in the room. So I have 3 questions for the audience. Question number 1. Who here was building and deploying generative AI models more than a year ago? Just raise your hand. Whoa, OK. So that's great, because everyone here is going to learn a lot. Who here is now starting to build generative AI models and deploying them? Awesome. That's great. And then last question, regardless of how you answer the first 2, who here thinks that we are in a bit of a hype for generative AI, and productization at scale is a couple of years away, if not a distant dream? OK, maybe the jury is split on that. Now, regardless of where you are in your generative AI journey and how you feel about generative AI, we really hope this session is useful and insightful. So with that, let's begin. So panel, my first question to you is really about the history of how we got to where we are with generative AI. Over the last decade or so, we've seen that investment in infrastructure and tooling has led to the creation of more sophisticated models, which has then unlocked many new use cases, and that has led to a wider adoption of AI and ML technologies. It has created this virtuous cycle. And all of you have touched various aspects of this flywheel. So talk to us a little bit about that. Talk to us about, from your vantage point, what have you seen unfold that got us to this place that we are at today? Ron, maybe you want to start?
Yeah, sure. So AI has been in a self-reinforcing cycle for more than a decade now. For me, it kind of started around 2012 with AlexNet. And just to set the context, neural nets have been around for many decades. But in the latest era of AI, in the last decade or so, we've been seeing again and again that as we scale model sizes and the training data sets, we continuously hit new state-of-the-art results. And this fits into the flywheel that you just described, because we get bigger and better models, and we continuously make the models bigger. That drives more use cases, applications, compute demand. That enables more infrastructure investment. And the better infrastructure allows us to build the next bigger and state-of-the-art models. So we see how this flywheel is accelerating, and we don't see any signs of it slowing down anytime soon. As for me specifically, I work on the infra side, building Inferentia and Trainium, as Shruti mentioned. Our goal is to accelerate this flywheel even further by enabling our customers with best-in-class infrastructure for their AI compute needs. And just today, we announced Trainium 2, which is 4x faster than Trainium 1. and I've been in the chip space for a while, 4x in a single generation is something significant. So our hope is that this will continue to feed this AI flywheel, and the community will use that infrastructure to build the next generation of state-of-the-art models.
Awesome. Jan?
So my AI journey started around 2009, and actually started in the context of Spark, Apache Spark. Many of you don't associate Apache Spark with machine learning platform, but that was our one of the first application on top of Spark. And that has happened at Berkeley, where we have these labs. And in these labs, we are actually, with few years before that, we decided, the faculty, to give up our offices and have an open floor plan, cubicles, and so to accelerate, to increase the interaction. At the same time, in the same space, we had people from different areas. It was machine learning, Michael Jordan and his students, and databases and systems and networking. So all these people were, in a very small area. And how did we get there? Because there was a problem to solve. And the problem which was to solve is that Lester McKee, who was a machine learning student, and a group of other machine learning students wanted to participate to this Netflix challenge. Anyone remember about Netflix challenge? It was $1 million for improving the recommendation engine, right? And these students came to us. I'm a system also infrastructure, software infrastructure. And they came to us and say, okay, how do you do it? Like, we have all this data, what you are going to use. And we happily send them to Hadoop. Use Hadoop, it's going to. And then they came immediately back to us, say, but it's slow, right? It's like, because, you have all this iteration. Every iteration, it's a MapReduce job. You write and and read from the storage all the time. And then, okay, we have a solution. And then Matei, which was working with me at that time, is also one of the co-founder and the CTO at Databricks, came up with the first prototype of Spark to solve this problem. And it was a few hundred lines of code. And the reason Spark is written in Scala is because it allows him to prototype much quicker than doing it in Java. So that's kind of the story. And then first customer, we have Databricks. We solve them because they thought that they want to use machine learning, right? So they were saying, well, it's aspirational, right? Even that was 2013. So we sell our product that we have back then, and to do the machine learning. But then after a few months, go back to them because they are happy customers and say, okay, what do you have? What did you build? And none of them are doing machine learning. Do you do anything about machine learning? Why do you do it? They say, well, is this data problem? Right? I don't have the data. I need to clean up the data. There is this kind of other data I need, and so forth. We are lucky because Spark was also great at data analytics and engineering. So that's kind of the story. And since then, I really focus on, from the software system side, about how to scale and these workloads. So, and we build a bunch of open source systems at Berkeley to do that. And why to scale? Because it was clear about when you see this kind of the demands of these machine learning workloads growing much faster than capabilities of a hardware, even with Trainium 2 and so forth. That was pretty clear 2014, 15, because it was going on since 2010. So, a bunch of systems, like after Spark was Ray, we scale up all these machine learning workloads like reinforcement learning, and more recently, this VLLM for improving the performance of the inference, all of them open source.
Awesome. Thanks for sharing that anecdote.
Yeah, so Ron is one of the co-founders of Databricks, where I now work. So I came there through the acquisition of my company that I founded back in 2021, Mosaic ML, and really we were focused on how do we bring these large-scale neural networks, and this is back in the ancient times, in like 2021. uh, where we didn't call it generative AI yet. They had generative abilities, but really it was about scale. How do I scale something and make it reliable and repeatable? And when I do that, I make it more accessible to many more customers or users. And so really, I think many of the problems that we talk about, AI safety, lots of these things are solved by many users, basically distributed capabilities, decentralization. And so that was really what fueled us then. And we attacked cost through algorithmic optimization and just building better learning models as well as software optimization. But my AI journey actually started. I was actually. It's interesting. I predate you, which is I don't know if that makes me old or what, but I've been in this field for a long time. I actually did research even as an undergrad in the '90s using like neuromorphic machines, things that were circuits that can behave like neurons. It's some of Carver Mead's work. I did some research then. Came out to Silicon Valley and actually designed chips, CPUs and other kinds of chips, and built software stacks on top of them. So always at the systems level, how do I translate algorithms to run efficiently on hardware? And actually in 2007, I wanted to go after this question of how can we build better computers? Computers that can learn from data. And again, in 2007, we just didn't think like this yet. Machine learning was like a obscure academic field then. There was a small community of people. I remember seeing Jan LeCun come and give a talk, and it was kind of like, God, this is a joke. Why are we even talking about neural networks, right? And I was like, no, this is great. This is great. This is going to be amazing. And at that time, it was everyone was talking about SVMs and regression methods. But anyway, I went back and got a PhD in computational neuroscience, so I could understand a little bit about what the brain does and how it works, and kind of view that from the perspective of a computer architect. And actually, there are a lot of concepts then that do translate over. And I ended up founding a company called Nirvana, which was one of the first dedicated AI chip companies. It was acquired by Intel. So I've been kind of in this field for a long time and seen a lot of these transitions. And it is really interesting to see this flywheel involve hardware. And that's almost a rate-limiting step here. Hardware capabilities enable scale with more data. They enable bigger models, better models. Those models then enable more data and then new capabilities that go into hardware, which takes another 2 years to develop. So it's this cycle, but it is somewhat rate limited there. But I think what I've seen from even like the late 90s to today is this push towards, instead of fully prescribed systems where I dictate what they do and I sort of delineate what they do up front, to learning systems which actually start discovering aspects of the task from the data. I think the watershed moment that Ron was referring to in 2012 was the ImageNet moment, when we saw a convolutional neural network finally have enough scale, both from the data and the computation side, to be able to start discovering features that were much better than what a human could engineer. And that was like, for me, a light bulb moment of just, okay, now it's time to start thinking about this as a new computational paradigm. And I think now we've stumbled upon the next one, which is not discovering features, but now actually discovering how those features fit together. You can call it knowledge, or I don't know, whatever you want to call it. But it's not over. There's a lot more to do. And each step of the way, we build new capabilities and new tools. I think the first wave, maybe it's the second wave, whatever wave, the 2012 moment gave us capabilities that we could start building face detectors and things that dealt with noisy data. Now we can start dealing with very large data, large corpuses of knowledge that we can start to query in more natural and imprecise ways. And I think that's going to be a tool that's going to fuel the next 5-6 years of growth. Next, after that, I don't know, agents, things that have agency, can actually take action and plan, I think is probably something that's 5, 6, 7 years from now. But it's a very exciting time, and hardware just keeps getting better and subserving all of this. One thing I'll leave you with before I hand it over is human brain runs on about 20 watts of energy. That's it. That's the story. For me, that is exactly our path forward. We got to figure out how we can get close to that in synthetic systems.
Thanks. So my background, I guess, is more in like traditional machine learning, things like linear models, random forest, that kind of stuff. And I got into it about 2012, 2014. And what really strikes me about Gen AI is how broad it is, how broad the appeal is. And I think one of the great things about it is how accessible it is. and that's driven a lot of the interest and hype around the space, because everybody can go and use these tools and see what they do and intuitively understand what's possible. Whereas I think before, machine learning was very like a niche thing, a very nerdy thing, kind of under the hood. I'm doing fraud detection, spam detection, things like that. Yeah.
Awesome. Okay, so thank you for sharing your backgrounds and experience. Now that we've talked about how we got here, let's discuss what here is. On the screen, you see a limerick that was written by generative AI about itself. And I don't know if this was possible 4 or 5 years ago. So today, are we in a hype for generative AI or not? And regardless of how you answer that question, what are some of the challenges that we need to overcome before productizing this technology at scale?
I can start. I think we're definitely seeing a time of heightened expectations from generative AI. It's very popular these days. But underneath the expectations, there's a genuinely transformative technology that we cannot ignore. I think it has the capacity of changing many aspects of our lives. And if you think about it, it already changes the way that we interact with computers even today. Just a few years ago, when we wanted to search the internet, for example, we would type a couple of keywords in the search bar, get a list of URLs, and then we would need to go through different websites to sift out the information that we're trying to figure out, to find. And over time, search has become way more conversational. And when we look at Gen AI assistants these days, we can ask a question and get an answer with the distilled information that we're looking for. And that's a much more natural way to interact with computers and with the internet. And the reason that many of us here are very excited about this technology is that if you take that and extrapolate out, you can see significant impact on our societies even. I mean, we can extrapolate just a line of sight and think about situations where every child in the world will have a world-class expert as a personal tutor for every subject that they're trying to learn, or where everywhere in the world you can get access to world-class healthcare. And again, this is just line of sight extrapolation. We're not going super far here. If we go further than that, we could even imagine a situation where Gen AI helps us solve problems that we don't know as a society, as humanity, to solve today, including curing diseases and whatnot. And I think if we go to whether it's a hype or not, I think the reality is that some of these Gen AI promises will not live to their expectations, but some will, and the ones that do will fundamentally transform our lives. I wouldn't be spending my time and energy on this if I didn't believe that. Just to close, I think one of the major aspects that we need to solve in order to make this technology much more accessible and dependable by the community is, first and foremost, guarantees on correctness or prevention of hallucination. Today, these models can sometimes generate wrong results with what seems like perfect confidence. This is the answer to the question that you're asking for. And we'll need to build capabilities to prevent that for us to rely more and more on this technology.
Yeah, so the question is whether it's hype. It's absolutely is hype. But with any new technology, you are bound to be, it's going to be hype. It was with electricity. People believe that, 100 years ago, everything will be electric. Nuclear power. The same thing. Everything will be powered by nuclear power, including cars, right? So every time people, like when there is something innovative, you are going to imagine everything you could possibly or impossible do with that thing. So there is a hype. But like you mentioned, it's like there is a revolution, right? It's like, and the way to look at that is that look at the facts, right? And what we have right now, we have a technology that is performing some of the tasks good enough, right? The results are good enough, right? So we can use those results. It's generative AI. What is generative AI? It's about generating solutions. And when the solution becomes for some task good enough, and then these solutions are actually hard to generate by humans, right? But it's easy to assess their kind of quality. That's kind of the combination. Good enough solutions, solutions which are hard to generate by humans, and it's relatively easy to assess their quality. If you look at the first generative AI application, which is text to image, right? DALL-E, right? Think about that. You have pictures which are good enough that you are going to use in some of your presentations. They are hard to generate by humans, right? By and then it's easy to evaluate. You look at it and say, okay, it's kind of what I want. When you use ChatGPT to write an email or marketing material for you, you need to tell what to do, and then presumably it's harder for you to generate that material, but at the end of the day, you read it and say, okay, this is good, maybe I'll do some changes. So I think that's kind of the key there. And by the way, I'm just going to, Naveen remind me about my, my prehistory actually. Actually, when and this is there is a big thing here is that actually I'm coming from Romania. In Romania, I started a PhD. My PhD was in neural networks. Then I gave up because it was the end of 90s. I came in US because it was something much hotter than. It was the internet. But the thing about is that at that time, it was toy applications. And I went to CMU, which CMU was a little bit of a cradle, at least in the United States, of neural networks. I took 2 classes also on that during my PhD. But they were kind of toys, right? It's like, it was more a proof of concept you can do. Right, I remember. So that's kind of, but right now, we went a long way, right? Starting to, so 2012, ImageNet and things like that. But really what you have right now, you have good enough solutions for some tasks, not for all tasks, but it's just a matter of time.
Yeah, and I would argue, I think we're all going to agree that we're in a bit of a bubble right now, which is fine. I think I was a young engineer during the .com bubble you referenced, and it was as an engineer and a technical person, I'm like, oh, that's crap. What is all this hype? It's ridiculous, But I've come to realize that's kind of how things work, and it works because once something has demonstrated enough capabilities to capture an imagination, people then put focus on it. They put energy in it. They put investment into it, and then you actually see college kids studying that thing. And I started to see this with AI and machine learning starting to happen. I don't know, you're a professor, maybe 2016, 2015, we started to see computer science departments teaching ML to undergrads. And so what happened? Those students in 2016 graduated in 2020. And those people are the ones who are innovating and pushing some of these things forward. So I think the hype is actually a mechanism that enables us to do these things, to make these big transitions. So I see it actually as not just a bubble or something to be, to look down upon, but actually it's how we make these transitions happen.
Yeah, I have to agree. There's definitely a lot of hype. I think in 2017, I was working for an insurance company, and they were sort of petrified of driverless cars because if cars could drive themselves, there would be no accidents and no one would need insurance, right? And I think that demonstrates how hard it is to actually take an AI system and turn it into a viable product that's kind of robust and reliable in the real world. And I think the point about being good enough is actually it's kind of how I look at Gen AI. It's something that's good enough, and I think people, like computers, are really good at doing the same thing very quickly, a lot. And Gen AI fits best where you have something that's good enough and you need to do it a lot, right, and very quickly. And I think those use cases are going to be the initial ones. As we get more robust models and better validation and things like that, we'll be able to use it more broadly. But for now, I think there's a lot of overinvestment, a lot of overpromising, and we'll see how it plays out. There's absolutely some valid cases there, yeah.
Awesome. We talked about the history of generative AI and the birth of the transformers, the models. The machine learning models was a pivotal moment. And today we see there are so many options out there. The open source innovation has been great. On the one hand, you have these really large-scale, sophisticated models. And on the other hand, you have smaller but still capable models. I guess my question is, if you had to bet your money, which approach would you bet it on? And jokes aside, how should developers and organizations think about choosing the right model for their use case, the right size of model, the right type of model, the right model architecture? Naveen, I know you have some thoughts on this.
Yeah, I mean, I think again at the beginning of these things, we look at like, as Jan said, one new tool can be the hammer for everything's a nail, but it's actually a lot more subtle than that, because I think when a technology takes over, it inherently becomes scaled. When something becomes scaled, it becomes expensive. When it becomes expensive, you start thinking about the dollars. So the economics of the world will always come back at you. It's sort of like the physics of business or something. And so I look at it like, well, big models are great. They have some interesting capabilities. Do you want to use them for everything? In an interview recently, I said, like, using GPT-4 for most use cases is like having a person with 2 PhDs do customer support for Nerf guns. Like, it doesn't make sense, right? It's too much of an overkill. It's very expensive per inference because it's a very large model. It uses a lot of compute. It doesn't make sense if you know a very precise set of outputs that you care about. So I think what we're going to see is there are going to be these big models that do some interesting things. We're going to keep pushing the forefront on them. And we're going to have this long tail of small models that actually power a lot of industrial use cases, because the economics matter, the latency matters, the ease of deployment of a smaller model matter. Better hardware from folks like Ron and others is going to enable that to grow over time. And what is small today what is big today will be small tomorrow. But I think we're going to have this long tail. You're not going to see one type of model or one model fit everything. That is just not going to happen.
Yeah, I not surprisingly, I totally agree with that. There will be, and we already see it, right? And you have, again, it depends on the task. But for many tasks, you already see that if you fine-tune a relatively small model, 7 billion, 13 billions, you can get results as good, if not better, than ChatGPT. So it's, again, the profit in the pudding, so to speak. But think about, you call this assistants, but think also about human assistants. In our life, we do the same thing. When we have something legal, we go to a legal expert. You want to prepare your taxes, you are going to go to an expert for that. So we do the same thing. We have experts in different areas, right? It's much harder, and the more tasks you have, the harder it is to have something which is work equally well everywhere, right? It used to be like a Renaissance man, right? In 16th century, Leonardo da Vinci and others. But that time is also it's gone. So you are going to have, like we do in our real life, we are going to have models which are really tuned to perform one particular task the best. And it's not only, again, it's going to be better accuracy, and as Naveen said, it's about also cost, right? And it's not only about cost, it's also about speed, about latency. A smaller model is going to have smaller latency, right? So that's kind of what you are going to have. And the complexity will migrate in the sense in that go one level up about, I have all these kind of 100 models, which one I'm going to use, right, for a particular query.
So, choosing the right model, type, size, architecture goes hand in hand with choosing the right technique to build that model. You could use something like fine-tuning or take sort of a RAG approach or go all the way to pre-training from scratch. How do you think about choosing that right technique? What are the factors at play? What are the considerations one should think about? Jan?
Yeah, so I think there are several, it depends about your use case and depends about how much data and how the quality of the data you have. It's as simple as that, right? If you are a company like, I don't know, Bloomberg or something like that, you have huge amount of data, maybe it's worth to build and to pre-train your own model. I think Naveen can say more about that. If you have a little bit less, but also high quality, and always you should try that, you can fine-tune one of the existing models. Actually, even at Berkeley, again, it's a lab, so we didn't have a lot of resources. But we early on, we fine-tuned this model Vicuna on data and high-quality data the shared GPT data, and for a while was the best open source models in terms of accuracy, and competing with ChatGPT at that time. So that's kind of it is. And then of course it's you have prompt tuning and all of these things, right? So you have all of these kind of methods and approaches, and all of them are good depending of where you are. But one constant across all of them, I think it is the quality of the data you have, right? It's incredible about how much of a difference high quality data can make in the ultimate results of building a model which solves a task very well.
Maybe just to add a bit to that, so I completely agree with what Jan said. As someone who's optimizing model day in, day out, just to touch on the performance optimization techniques, it's really hard to track all the different performance optimization techniques that get published all the time. But essentially, you can think of a group of techniques that became table stakes, that everyone needs to implement them. You can think of tensor parallelism, you can think of flash attention, also KV caching during deployment. So there's no question, you'll see them implemented every single time. There's also a set of techniques that are quite case dependent. As an example, I can give continuous batching, but there are others, interleaved pipelining. So there are some cases where you'll need to evaluate a technique against the application that you're trying to build. And I think one of the good mechanisms that many try to employ, and I think it's very useful, is to track what others in the field are doing, like Mosaic ML, now Databricks, like Hugging Face. It's good to track what are the critical optimizations that many folks are implementing into their models.
By the way, the way we get around that, we have a guy who literally does an exhaustive search. He reads every paper on arXiv and summarizes the good ones. And he has a newsletter. So that's how we stay on top of it. It's like exhaustive search. It's insane, right?
Well, I was just curious. Maybe we'll build a model that can do that for us, and then just spit out all the.
We have a summarizer model that's supposed to pick out interesting ones. It's actually pretty good. We're basically taking the guy who did this and using that as a data set.
Excellent.
Just one thing to say is that the reason is that summarization for papers is good is because they can pick the information, especially if the paper is well written, from the introductions and the abstract. This is what they do. But be careful when you use summarization for things which are really, really important, like summarizing legal documents. We are not there yet.
Yeah, I think in choosing which kind of approach to take when building the model, it should also be a function of like capability and experience. Like I see a lot of people dive straight into large-scale pre-training, and it's like you just don't need to do that. I think there's so many amazing open source models. You can start very simply, work with what data you have, and come up with a great model. And then once you've gone through that process and understood what you're getting and how it works, then you can look if it's really worth taking the next step and getting to more advanced forms of training.
Yeah. So say you've chosen a model, you've decided to either pre-train it. Now, to deliver a delightful user experience, you need to deploy the models in production for inference, because the magic is built in fine-tuning and pre-training, but your users really experience it when it's deployed. What are some of the technical considerations to make sure that users have a great experience, and what are some of the pitfalls to avoid? Pete, sure. You have several models in production within Leonardo.ai.
Yeah, I think to have a great user experience, you probably don't want to think about the technical side of things. I think as technical people, it's very easy to get kind of caught up in the love and how amazing these models can be, right? But when people are trying to achieve a task, and you want to give them a good experience, you want to think about what outcome they're trying to achieve. And so you take an outcome-based approach rather than just a technology-based approach. And I think particularly with Gen AI, I don't want to say that there's a novelty to Gen AI. Like it's very new, and you can kind of go and talk to ChatGPT and make images. But after a while, you're like, I don't need 1,000 pictures of a cool dog every day, right? And I think that plays into building great products. And one of the other things about making a good UX is chaining several smaller models. I think you have so many models that can do so many different things, and they're all very powerful. And so for text to image, you might take a basic prompt and use an LLM to make it more elaborate, which gives the user a better image, and they don't necessarily have to know that that's happening under the hood. And then finally, I think you can use these models to engage better with your users. So you can engage with them in their native language through different modalities. It doesn't just have to be text. You can use images to make your content more engaging. And all of these things happen under the hood. And I think that's what creates a great user experience around AI.
Anyone else want to add?
Yeah, I mean, what we're seeing actually from some of the customers that have built models with us or tuned models or served them is that, to your point, they're actually putting together models in these ensembles kind of, and either chaining them or using things to route different information to different models. For, I think that it really depends on the application, but if you think backward from the product and what you're trying to deliver, then you think of the LLM or the diffusion model or whatever as a set of modules that you can kind of bring in. And I think this is actually, it's going to be explored a lot over the next several years. I don't think anyone really understands this. There's a couple of companies that I've seen, like Perplexity AI is doing some really cool stuff here, and a few others, but it's really new, and no one's really made things work. I mean, people got really excited about agents for a little while. They don't work because autoregressive models don't really do that. And I think there's a lot of dead ends that people have gotten excited about, but we're going to find this kind of application layer on top, which is actually, I think, where a lot of value is going to be accrued per vertical. And so this is an area where I think there's a lot of opportunity if you're thinking about building something.
Just to tie it back to choosing the right model size, user experience ties back to that as well, because if you're building a speech-based AI assistant, you don't want a long pause from the time you ask a question until you get a response. So that's another reason, user experience is another reason to not go with a gigantic model, but rather something that you can kind of squeeze the latency and get a very instantaneous interactive use case.
Now, we'd be remiss if we did not discuss this topic of capacity. Today, due to the global AI chip shortage, resource availability and not just resource cost is becoming a gating factor for innovation, especially at smaller companies. What is your advice to these organizations? How should they navigate this situation?
I think, yeah, we're seeing it day to day, that getting capacity with all the AI innovation experimentation that is going on, getting the right amount of compute capacity is a challenge that folks need to deal with. It does tie to stuff that we talked about before. So if you don't have to pre-train your model, if you can start with fine-tuning just for a proof of concept, that would require a much smaller cluster. And of course, we're at AWS here, so I would definitely advise embracing the cloud for that, because you get the feature of elasticity. We call elasticity the capability to scale your compute cluster up and down according to your needs, and that flexibility matters a lot, because you don't really know typically you don't really know what would be the exact compute demand through the next 2 years. So if you can kind of get some more flexibility there, that matters a lot. Another advantage that you get is that you get a very broad set of options of hardware to use. So you can kind of pick and choose the most optimal hardware for each and every use case, and you might be running quite a few models at the same time. And I think as one very concrete approach, and I've seen teams that are not doing that, so that's the reason I'm saying that, is optimize for performance before you scale to a very large cluster. It doesn't make sense to gather all that compute and just use it for 20% of the time. So make sure that you squeeze every piece of performance from your compute cluster before you go big.
That's why you use Databricks Mosaic. That's what we do. But I think what's really interesting is we're seeing now in this kind of dense compute field, like basically matrix, vector math, engines like Trainium and GPUs, that you can't separate the neural network workload that far away from the hardware. The hardware is kind of consumed by that workload. Whereas with CPUs, like the entire cloud, we're at AWS's conference, the entire cloud was predicated on the fact that basically the hardware was kind of sitting idle most of the time, and I can time slice it very effectively and sell it over and over again. With AI, you can't really do this. And actually, that's part of why we have a shortage. And then building these devices is actually complicated. I don't think people understand when they say, like, we just need more capacity. We literally can't build more. Like, we don't have enough jigs and machines to do the packaging of these chips. I was in that world for a long time, and I think we're building more of those, but you have to build more jigs before you can build more capacity in the world. This is not like a US problem or something like that. So capacity is going to be important. I think we did have a little bit of this sort of tulips excitement for the last couple of years, and that is going to die down. But there's, like we talked about, the hype is there's something underlying it that's real, and we're going to see a greater share of wallet move toward compute. Humans become a little bit less important in the equation in terms of cost. Compute becomes extremely important. That's not going to go away.
Yeah. So regarding capacity, a few things. First, that's another reason to use small models, right? To state the obvious. But I think that what happens today is that a lot of complexity has, the complexity of our hardware environment is increasing dramatically, right? When we did Spark, the big thing was about distributed. It has to be distributed engine, but all the cluster was homogeneous. It has a CPU and some, hard drive at that time and SSD. When we started Ray, we were already thinking about, we need also to support GPUs in the language itself to expose to the programmer. But right now, if you think about, so there are two axes. You need to distribute these workloads, but the other axis, you need to deal with all this heterogeneity of resources, right? You have NVIDIAs, and you have Trainium, and you have inferentia if you do inference, and if you have TPUs, and you have AMDs, and you have Maya from Microsoft. So right now this, and by the way, and if you look at only one vendor, there are a plethora of chips which are good for different workloads, for different models. Like think about NVIDIA, L4s, A10s, and so forth. And so if you really want, if you are a small company, you need to be very kind of thoughtful and agile about what resources you are going to use. Let me give you an example. Like, for instance, again, another problem which is in the cloud, aside from what Navim was saying about, it's a little bit this kind of elasticity breaks, is that the resources are not available when you want. Go and get some H100s. Good luck, right? So what people do, right? It's like when you don't have food, you hurt, right? You buy and you reserve the GPUs for a long time, and you are creating a virtual data center for yourself, which, by the way, these nodes you are not going to use all the time, but you get them because you have a fear that when you need them, they are not there, right? So instead of doing that, look at the GPUs that are already available, like A10G, right? It's a good GPU, for instance, for 7B models, right? Actually, it's the most cost-effective for summarization, for instance. So that's kind of, but for that, you need software. I think the software, you are still scratching the surface. Because the software needs to fill the gap, needs to make it easy for you as a developer, and to abstract away all this increasing complexity. So you need to be on top, look up of software infrastructures which can provide this abstraction to accelerate your development and to be very effective in using whatever resources are out there. In your region, across regions, maybe in other data centers and so forth.
Yeah, I think you just work with what you've got, right? I think that's what he's effectively saying. And if most people don't need to get thousands of H100s to build the next ChatGPT, right? And even to have the knowledge and the know-how to do that is kind of a journey that you have to go on. And a lot of the companies I see trying to adopt AI aren't there yet. And so even if that's what you should actually be doing, that's the right answer to your problem, but you can't get the capacity, there's still other things you can be doing with AI and building that institutional knowledge and the organizational knowledge, because building a large-scale model is a lot of work, and it's a very detailed, expert work. And most organizations probably don't have that skill set already. And I think that's something you can start work on today and now with lower tier GPUs, for want of a better phrase, but and bet that in time they're going to become more available. They are going to get faster. The models will get smaller. All of these things will happen, and it's almost inevitable. And so even if today isn't perfect, you work with what you've got, and you can kind of bet in the future that it will eventually get there.
Great. What you said, Jan, reminded me of two things. One is we have a customer, AWS customer, based in Europe. Their name is Codeway, and they came to us asking for A100s. And through conversations with our solution architect team and through their own exploration, because they couldn't get the capacity that they wanted, they figured out a really cool solution where they realized that some subset of their models didn't need the A100s because their latency requirements were not really as tight as some of the others. And they could move to our A10Gs, which is the G5 instances, instead of the unavailable and expensive P4Ds. And that really just made it so much easier for them. So,
sorry, and if it's A10G, doesn't provide you enough latency, hey, you can stripe the model, across multiple A10Gs to reduce the latency. There are techniques doing that.
Yeah. And then the second thing that you reminded me of when you said that people have this fear and they reserve capacity. So I'd be a bad marketer if I did not mention that AWS just launched a capability a couple of month ago. It's called EC2 capacity blocks for ML. It's the only consumption model today that can let you reserve compute capacity, short-term compute capacity for the future. So it's literally like going and making a hotel reservation and
Not the only one. We actually started that.
Oh, okay.
I think it's actually a copy of this idea of I can reserve a large block for pre-training, right?
Okay.
For short-term basis, but yeah.
Okay, I will have to go back and check our stats. We did advertise it as the first of its kind consumption model from a major cloud service provider. Let's just say that.
Fair enough.
Is this being recorded? Anyway, so please check it out. The intention behind that is it will give you a lot more predictability, and you can plan for your development cycles and reserve capacity only for the time you need it. So those are the two things that come to mind. Okay, so I'm very cognizant of our time. We have about 12 minutes left, and I really want to leave some time for audience Q&A. So with that, this will be my last question to you, panel. Today, so many people are being asked about their generative AI strategy. And it almost seems like, regardless of what the question is or what the problem is, generative AI is the answer. What is your advice, or what are your top 3 takeaways for organizations looking to build generative AI-powered applications?
I think I've probably got two points here. One is, start small and start simply. I probably said that a few times. And it's more important to get something up and running and see it in practice and end-to-end integrated with your systems to understand what that actually looks like and to understand what all of the vendors and everyone else you see are actually talking about. It gives you that context to make sense of what's actually going on. And then I think the second thing is kind of on the other end of the spectrum where you should, I've seen people try and kind of lift and shift AI into their existing business processes where they have a process and say, AI is going to do this, AI is going to do that. And that can work, but I think the real value really comes from sitting back and kind of looking at these new models and their amazing capabilities and thinking about the nature of the work that you actually do in your business. So rather than just trying to map a process to an AI, say, AI can do this for me now. What should my humans be doing and what should my computers be doing?
So yeah, I think we've seen this. We deal with a lot of customers who are going down this journey, and some of the advice we give is be very clear about what the problem statement is. And when you do that, then you actually start to understand the constraints. Is it latency bound? Does that matter? If it does, then that's something you need to think about. What are you replacing, and what was the scale of that thing? Because when you understand the scale, you can actually make very rational choices now. So it's not going to be that GPT-4 is going to be the best solution, most likely, if it's a high-scale problem. You need to now think back, like, okay, if latency really matters and I'm going to have like 1 billion inferences a day, now I need to start thinking about something smaller, and then I got to think about a strategy to get there. So really kind of being crisp about those things is important. I hate to say this as a technologist, but it's almost like a discounted cash flow DCF model or something. Understand what you're generating, and then kind of back calculate what you're going to put into it, and that's an important consideration.
Yeah. So a few things. So the first, and it's about you need to be very clear about the problem you want to solve, about the task you want to accomplish. And then it's again, it's like, because I've seen this, it's like, remember, generative, at least at this stage, AI is about generating solutions, not necessarily correct solutions, right? That's why we are talking about, it's like being confident, very confident about, generating something wrong. So it's very important to know that there is a relatively easy way to assess the quality of the solution, right? Right. That's kind of is very important, because otherwise, if there is no easy way to assess the quality of the solution, you can get into trouble, right? So this is a good pattern. Something which solution is hard to generate, but easy to check. And again, what check means, it depends again also on the problem. Right? If even for the same task, like we were discussing earlier, if I summarize a blog or a paper, it's fine, right? But if you do it legal documents, if there are mistakes, it is a problem. And the only way to check really for that is to read the legal document, which is a lot of work to do. If I read the legal document, probably generating a summary is not a big deal, right? So I think that's kind of the way I think about. The other thing I will always look, can an open source model do the job if I fine tune it? And again, depends on the task. We are talking about, for some tasks, with open source fine tune models can beat ChatGPT. However, there are other tasks like reasoning, solving math problems and so forth, which it seems that the size of the model still matters, right? Okay. And the other one, it's about, obviously, the scale. You need to have some idea about the scale, because, again, sometimes lift and shift will not work. If you have huge traffic and you want to replace a component of your existing system, backend system, with some LLM, it can be 100 times more expensive.
I think I'll step back a little bit and kind of say, if you're not using generative AI, just don't overthink it. Start experimenting with it. It's probably easier than you think. With all the foundational models, you can just kind of fine-tune something and get the proof of concept up and running very quickly. And I think it matters a lot, because it's a revolutionary technology. It's good to know what its capabilities are in order to understand its impact on your business and how you should approach it. But of course, if you're in the room, probably you are embracing Gen AI. So the other comment I would make, or advice I would give, is related to what Jan and Navin said. Think about deployment early on. I see too frequently that people are training a model and only bother to think about getting the best quality out of the trained model. But then after the model is trained, if that's the point where you start thinking about deployment, you're going to be bound to a box, and you won't have any flexibility to shift left or right to the place you want to get to.
Awesome. Thank you so much for such an insightful conversation. I definitely learned a lot. I hope you all in the audience did as well. Thank you, everyone, for joining, and thank you to the panel.
Thank you.